Welcome to CS 1401 Video 11.1, which introduces the idea of modular programming. Modular programming means decomposing your overall program into separate subprograms. For example, if your program asks the user to enter a value at multiple places, and if you need to check each entered value for validity, is it an integer? Is it non-negative? Does the string not include the slash character? Then write this as a subprogram and call it when you need to validate each value entered by the user. Modular programming was developed in large part to avoid the problems of what is called spaghetti code. Before the widespread use of subprograms, programmers would create long and complicated programs that had jumps to various places in the code. This made programs hard to understand, hard to debug, hard to maintain, and hard to revise. Control flow in programs jumped around from place to place, and understanding this flow was like trying to untangle a plate of spaghetti. The early programming language Fortran was developed in the 1950s, and it was the most widely used programming language for decades, and it's still in use today. In Fortran, control flow in a program was handled by the go-to statement, which worked basically the same way as the jump instruction in assembly language. The most famous academic paper in all of computer science is undoubtedly the 1968 paper by Edgar W. Dijkstra entitled Go-To Statement Considered Harmful. Dijkstra made the case that controlling program flow with jumps, in other words, spaghetti code, made programs prone to errors. This observation led computer science to develop increasingly structured approaches to programming. And today, software developers provide structure by decomposing programs into subprograms. Programming with subprograms has a number of benefits. Subprograms enable reuse of code. If a program does the same thing more than once, it's better to write a single subprogram and call it from the main program every time it's needed, rather than having to insert the subprogram code each time it's used. That leads to problems with consistency and maintenance and just makes things more complicated than they have to be. Subprograms make your program easier to read and to understand because you can see the main structures. Subprograms have explicit arguments that show exactly what information a subprogram uses. This helps you understand what a subprogram does and doesn't do. Subprograms reduce the chance of mistakes. Subprograms that use local variables reduce the chance that the code in the subroutine interferes with that of the main program or of other subprograms. And subprograms can separate tasks such as output. In other words, output code tends to be long and detailed. We've seen this in our own programs. So including this in the main program can obscure the critical elements of the program. In general, subprograms are referred to as subroutines, functions, procedures, and methods. Subroutine is an old-fashioned term, and today it basically means the same thing as subprogram. Generally, a function is a subprogram that returns a value. In general, a function should not affect the values of its arguments. For example, m equals square of n should assign the value of the square of m to n, but it should not change the value of m. A procedure is a subprogram that does not return a value. Its results have to occur via what are called side effects, changes in the state of the program. These side effects could include producing output or changing the value of a variable. A method is what a subprogram is called in Java. We can write a method that works like a function. It returns a value while not changing the value of its arguments. Or like a procedure, it produces side effects such as producing output or changing the value of a variable. Here is an example to show the difference between a function and a procedure. Let's return to our pseudocode algorithm to print a table of squares. So my algorithm is going to be called print squares, and it will take one integer argument n. I'll declare a new integer variable called I squared, and then have a for loop. The loop will run from I equals 1 as long as I is less than or equal to n. So it will run n times, and will increment I each time the loop executes. The body of the loop calculates the value of the square of I and assigns it to I squared, and then prints our table entry, in other words, the value of I and I squared. Now, let's look closely at the assignment statement. That's a function call. The function will be called square. It will take a value as an argument, that is I, and return another value, I squared. But it's not going to change the value of I. The subprogram print square entry is a procedure call. It doesn't return a value. It does something, in this case, produce some output. So now we can define our function square of n and our procedure call print square entry. The function is pretty simple. It just says the square of n, when we call it, should return n times n, or n squared. The algorithm print square entry, our procedure, takes two arguments, n and n squared, and it's also pretty simple. It just prints out a line saying n squared is n squared. Now, if I were really writing this program, I probably wouldn't have a function call and a procedure call in a program as short as print squares. I just calculate n times n and do the print line in the main algorithm. I'm doing it this way so that we can see, for educational purposes, how a function and a procedure call work. In the next video, I'll discuss implementation of subprograms in Java by writing methods that work as functions and procedures. I'll see you shortly.